Could the water you're drinking every day be quietly undermining your health without any obvious signs? Understanding the safety and quality of your drinking water is crucial for maintaining good health. Here's a detailed look at how you can test the purity of your water and make sure it's safe to drink. Hello everyone, welcome back to our channel Clean Hydration. Today in this video we will be talking about what all you need to know about chemical water purification at home. When looking for clean and safe drinking water, many people use chemicals to purify their water. But how can you tell which chemicals are safe and really work for home use? This guide explains the key things you need to know about using chemicals to clean your water, helping you choose wisely and keep your water safe. What is chemical water purification? Chemical water purification is a method where specific chemicals are added to water to remove harmful organisms and contaminants. This process is designed to make the water safe for drinking by killing bacteria, viruses, and parasites that can cause diseases. It also helps remove or reduce other impurities, like metals or chemical toxins that might be present in the water. This technique can be used on a large scale by city water treatment facilities, where water is purified before it's distributed to homes and businesses. It's also used at a smaller scale in individual homes, often through products like water purification tablets or liquid drops that contain the necessary chemicals. This approach is particularly useful when clean water sources are not readily available, such as during camping trips or in emergency situations. Common chemicals used in water purification. Number 1. Chlorine. Chlorine is one of the most commonly used chemicals for water purification. It is highly effective in killing bacteria, viruses, and other microorganisms that can cause disease. Application. It can be applied in various forms including liquid, gas, or in granules. Advantages. Chlorine is cost-effective, easy to use, and quick in action, making it a popular choice for large-scale and home water treatment. Number 2. Iodine. Iodine is another chemical used to purify water, known for its effectiveness against a broad range of pathogens including viruses and bacteria. Application. Available in tablet, liquid, or crystal form, it is particularly favored for small-scale or emergency situations. Advantages. It is lighter and easier to transport than chlorine, making it ideal for travelers and outdoor enthusiasts. Number 3. Chloramine. Chloramine, a combination of chlorine and ammonia, is used as a secondary disinfectant in municipal water systems to help maintain water quality as it moves through pipes. Application. Used primarily in municipal systems, it is less likely to form harmful byproducts compared to chlorine. Advantages. Provides longer-lasting disinfection as the water moves through distribution systems. How do these chemicals work? Mechanisms of action. Chlorine. Chlorine kills organisms by breaking down cell membranes and disrupting processes inside the cells. It also reacts with water to form hypochlorous acid, which is highly toxic to many organisms. Iodine. Similar to chlorine, iodine penetrates the cell walls of microbes and disrupts their internal structures, rendering them inactive. Chloramine. By combining the effects of chlorine and ammonia, chloramine provides a more stable and longer-lasting disinfection process, which is less reactive with organic compounds in water. Benefits and risks. Benefits. Chemical disinfectants are effective at reducing disease-causing organisms in water, improving water taste, and are generally easy to manage and apply. Risks. Improper use of these chemicals can lead to health issues, such as thyroid problems from excess iodine, or increased cancer risk from chlorine byproducts. Environmental concerns also arise from residual chemicals reaching natural water sources. Pros and cons of chemical water purification. While chemical water purification is a powerful tool in the quest for clean drinking water, like all methods, it comes with its own set of advantages and disadvantages. This chapter examines these aspects to provide a balanced view, helping you understand when and how to effectively use chemical treatments at home. Advantages. Number 1. Effectiveness against pathogens. Chemical disinfectants such as chlorine and iodine are extremely effective at killing a wide range of pathogens including bacteria, viruses, and protozoans that cause diseases like cholera, typhoid, and dysentery. This makes chemical treatments invaluable in areas where waterborne diseases are prevalent, or during emergencies where water safety is compromised. Number 2. Cost effectiveness. Compared to physical filtration systems and advanced treatments like reverse osmosis, chemical purification is significantly cheaper both in initial setup and maintenance. Context: this affordability makes it accessible to a wider population, ensuring that more people can have safe drinking water. Number 3. Ease of implementation. Using chemicals for water purification does not require complex equipment or substantial infrastructure, which is especially beneficial in low-resource settings. Context: treatments like chlorine tablets or iodine drops are easy to distribute and use, making them ideal for disaster relief operations and individual households alike. Disadvantages. Number 1. Health concerns. Long-term exposure to certain chemicals used in water purification can pose health risks. Chlorine, for example, can react with natural organic matter in water to form disinfection byproducts like trihalomethanes, THMs, which are linked to cancer and reproductive issues. Context: these risks necessitate careful management of chemical levels and regular monitoring of water quality. Number 2. Sensory and aesthetic impacts. Some chemicals can alter the taste, smell, and color of water. Chlorine, for instance, imparts a noticeable taste and odor that many find unpleasant. Context: this can lead to reluctance in using chemically treated water for drinking and cooking, affecting user compliance. Number 3. Environmental impact. Improper disposal of chemically treated water can lead to environmental pollution. Residual chlorine and other chemicals can harm aquatic life if they enter rivers, lakes, or groundwater systems. Context: this highlights the need for responsible chemical handling and adherence to environmental guidelines to minimize negative impacts. Number 4. Limited effectiveness against some contaminants. While effective against microorganisms, chemical purifiers do not remove all types of contaminants. Chemicals like pesticides, heavy metals, and other pollutants require additional filtration or treatment methods. Context: this limitation necessitates a combination of purification techniques in areas where water is heavily contaminated with non-biological agents. Now let us discuss how we can implement the chemical water purification at our homes. Implementing chemical water purification at home can be a straightforward process, but it requires knowledge and attention to detail to ensure effectiveness and safety. This chapter guides you through setting up your own chemical water purification system, from choosing the right chemicals to regular maintenance practices. What you need to get started. Number 1. Choosing the right chemicals. Before selecting a chemical, consider the specific needs of your household, the local water conditions, and any known contaminants that may be present. Popular options. Chlorine and iodine are commonly used, but factors such as the presence of organic matter, the desired contact time, and taste preferences might influence your choice. Number 2. Equipment and supplies. Chemical dispensers. Devices that automatically measure and release the correct amount of chemical into the water. Protective gear. Safety goggles, gloves, and masks to protect yourself from accidental exposure during the handling of chemicals. Storage containers. Non-reactive storage containers that are safe for holding chemically treated water. Number 3. Safety measures. Always follow the manufacturer's instructions for handling and storing chemicals safely to prevent accidents. Preventing contamination. Ensure that all equipment is clean and sterile before use to avoid introducing new contaminants into the water. Step-by-step guide to purifying your water. Number 1. Preparation. Measuring chemicals. Learn how to accurately measure the amount of chemical needed based on your water volume. This might involve calculating dosages or using pre-measured tablets. Pre-treatment. If your water has visible particulate matter or is discolored, pre-filter the water too. Remove solids before adding chemicals to achieve better results. Number 2. Purification process. Mixing. Dissolve the chemical in the water thoroughly. For gases or liquids, this may require stirring or shaking. Contact time. Allow sufficient time for the chemical to work. This time varies depending on the chemical used, but typically ranges from 30 minutes to several hours. Confirmation. Use chemical test strips to confirm that the right concentration of the disinfectant is present in the water after treatment. Testing and maintaining safe water. Number 1. Testing kits. Importance of testing. Regularly test your water to ensure that the chemical levels are safe and effective. Test kits for chlorine and other chemicals are readily available and easy to use. Frequency of testing. Testing frequency should increase with the volume of water purified and the sensitivity of household members to contaminants. Number 2. Maintenance tips. Regular checks. Regularly inspect your equipment and set up for signs of wear or malfunction, which could affect the efficiency of water purification. Record keeping. Keep a log of purification results, maintenance, and any issues to monitor. Performance over time and adjust processes as needed. Making the right choice for your home. Choosing the right water purification method for your home involves careful consideration of various factors including local water conditions, household needs, and personal preferences. This chapter provides a structured approach to evaluating these factors and making informed decisions about water purification. Factors to consider. Number 1. Water quality in your area. Understanding local water conditions. Start by obtaining a water quality report from your local water authority. This report can tell you about the contaminants present and any specific issues that need to. Common contaminants. Look for contaminants like bacteria, viruses, heavy metals, pesticides, and chemical byproducts. Each of these may require different treatment methods. Number 2. Household needs. Daily water usage. Estimate the amount of water your household uses daily. This will help determine the capacity of the purification system needed. Health concerns. Consider any health issues that may require more stringent water purification, such as immune disorders or allergies to certain chemicals. Taste preferences. Some methods of water purification can alter the taste and odor of water. Consider the preferences of your household members. Number 3. Budget and maintenance requirements. Initial cost versus ongoing maintenance. Weigh the initial investment against the ongoing maintenance costs of different water purification systems. Some systems, while costly up front, may have lower long-term costs. Maintenance skills. Consider whether you will manage maintenance yourself or if you will need to hire a professional. This can significantly affect your choice and the overall cost. Expert advice. Number 1. Consulting professionals. Water treatment specialists. A consultation with a water treatment specialist can provide personalized advice based on your specific circumstances. Local authorities. Local health departments can offer guidance and recommendations on appropriate water purification methods for your area. Number 2. Custom solutions. Tailoring to your needs. Based on your specific needs and the expert advice you receive, consider customizing your water purification system. This might involve combining methods, such as chemical purification with mechanical filtration or ultraviolet disinfection, to ensure comprehensive protection. Chemical water purification can be a good choice for cleaning your home's water, but it's important to know about the possible challenges and how it works. Learning about the benefits, risks, and how to use these methods correctly will help you decide if it's the right way to ensure your family gets safe, clean drinking water. That's a wrap for today's video. I hope you benefited from today's video. If you did, please do like, share, and subscribe to our channel and press the notification bell to get updates as soon as we post a new informative video. Thanks for tuning in.